All right, so first of all, what is the internet? So web development is just one of many applications that are built on top of the infrastructure that we refer to as the internet, right? So let's talk about the internet. And so the internet is the infrastructure on top of which the World Wide Web, the web, right, is built on, right? It runs on. Right? And the infrastructure consists of a whole bunch of computers that are connected all over the world, right? And they can send and receive messages between them, right? And now this network is the result of many years of research, right? That's started in the military, right, as a means to survive the World War III, right? The United States in the 60s, right? They had started looking back on past wars, right? Asking themselves how did they survive World War II, right? How is it that they won? Why did they win? How did they beat the Nazis, right? And then they were concerned that they were in the middle of the Cold War, right? And concerned that what happened to the Nazis might happen to us, right? Why do they lose? How do we beat them, right? So they came to the conclusion that we bombed the heck out of them, right? We disrupted all their means of communication, either electronically, radar, and certainly terrestrial, right? And they couldn't fly, they couldn't drive, they couldn't communicate, right? So it made it somewhat easier for us, to be able to overwhelm the Nazis, right? And so looking back at the analyzing this, how the U.S. started asking, well, how could we survive, right, if we ever get invaded, by the Russians or whatnot, and says, okay, well, how can we make sure that we're not in the same predicament that we are not when unable to communicate, right? So a lot of infrastructure focus was on the highway systems, right, and airports and whatnot, the physical infrastructure, but also a lot of research went into communication infrastructure, right? So the military started investigating, creating a network that was very robust, that was heavily decentralized, right? That there was no central point of failure. There was no one single point that you can attack, destroy, right, and just disable the communication system, right? So there are a lot of versions that were researched, right? And but in the 80s, some of these infrastructures, right, started to coalesce around a consistent infrastructure that happened to become what we know as today as the internet, right? It used to be exclusively military, but as it progressed, right, more and more institutions were allowed into this research. Certainly a lot of universities and research institutions, not only here in the United States, but across the world, and allies in Europe, right, Australia, Japan, right, that started to participate in this, large scale network of networks, right, that would allow us to communicate. And so in the late 80s, right, there was the Cold War was was coming to an end, right? The Berlin Wall was about to fall, and the famous speech from Reagan, Gorbachev, bring down this wall, right? And so all these research that went into the internet, and they a lot of things started to be decommissioned, right? And certainly many other more secure versions of the internet that was specifically only military, with no other institutions, right? No public access. And certainly they had their own version of the internet that is very secure, right, within the military. But this version of the internet, the Department of Defense started to look at ways that it could make it publicly available, perhaps to industry, right, to private sector, and started looking at, well, who might be interested in this, right? So as it included more and more folks, some folks were looking at what can you do with it, right? This huge infrastructure. Well, there was one particular individual, Tim Berners-Lee at CERN, that he was looking to share in the research work in physics that he wanted to share with his colleagues, right? And so up to that point, there were certainly many other tools that were available that scientists could use to share their findings, right? There was there was FTP, there was SSH, right? There was SCP, there was email, certainly, right? There was all these tools that can convert ASCII files into PDFs, right? That you can have all these tools that can work together that would allow you to publish research papers, right? To share them across multiple computers. So this was already there, right? It's not like there was no way for scientists to share data among themselves. There was file servers, right, that shared data and whatnot. So all this existed, all the infrastructure existed, but there was no easy way to bring all these tools together. So Tim Berners-Lee had a great idea. It says, okay, well, instead of having to use tons of tools to convert data and text, right, into readable articles, right, that you have to log into a server, right, do an FTP and transfer data here and there. Why don't we create a single, why don't we marry several of these tools into one big tool, right, that work together. And so inadvertently he invented the World Wide Web, right? For the formatting, he came up with the HTML, right? For the rendering of the content, he invented the first browser, right? A browser, a tool, right, that was able to navigate to a server, download the documents, right, from multiple servers, right, and then coalesce the content into one single document, right, and render it right there and then. No need to compile, no need to download the file, that run a compiler, right, and then run a viewer, right. So he brought it all together, and also the server, right, that hosted all this data. He came up with that as well. He also came up with a nice, consistent way to be able to reference, right, documents amongst each other, right. That you could have text that you can click on the text, right, and then it would download that other document, right. You can navigate between these web pages, right. None of this existed until he came and invented the entire World Wide Web on his own, right, at the end of the 80s, right? And after that, it's just exploded, right? The content just, he lowered the bar for, faculty and students and just all sorts of people, right, starting to create their own content, right? So now this internet huge infrastructure, right, now became accessible, right, to folks that wanted to create content. And so, yeah, so you have all these clients being browsers, right, connecting to these servers or interconnected amongst each other. And now we're going to be focusing on one of these boxes, right, where we're going to be building something like this. We're going to be building this client server architecture where you have the client being browsers, right, that are going to be making requests, HTTP requests to servers, right? That servers are going to be running a Node.js server that are going to be where the client is going to be asking for specific resources, and the server is going to go fetch these resources, either JavaScript files, HTML, CSS, right? And then they're going to send them back to the client. The client is going to coalesce the HTML, coalesce it with the CSS, run JavaScript, right? And then programmatically is going to render the content here in the user interface, right? Now, some milestones, just as we progress through history, right? In the 60s, we right the Defense Department focused on the infrastructure, implementing the internet, right? In the 70s, after having tried out many different types of architectures. One in particular became very, very prominent, right? And it's still widely used today is the client-server architecture, where some computers have a specific role, where the server was the repository of the resources, right? The databases, the files, right? The printers, right? Had all the all the documents, right, all the data, and it usually is typically it's a much more powerful machine, right? That might can get requests not from one user but multiple users. So multiple requests might be coming in from multiple client applications, right? And the server has to round robin and send the responses back to the multiple clients. And then you have the client, you have multiple clients, right? That are just other computers, right, connected to the same infrastructure of the internet that are making the requests, right, for the server to do some work, right, to do some computation, some rendering, some database access, whatnot, right, and then send it back to respond, right, to the client. Now, this typically was where the servers were a very powerful machine, perhaps in a room somewhere with air conditioning, right? And it was a server room, right? And it was a very powerful machine meant to be used by multiple clients, where the clients typically were kind of like rinky-dinky, small, very underpowered computers, mostly just for display, right? Display and a keyboard. That's it. Maybe a mouse. But then in the 80s, right, you have the advent of the personal computers, right? The first Mac, the first PCs, right? MS DOS, where now folks could have a fairly more comparably more powerful computer, right? That they could take home, right? That it wasn't a terminal that I needed to use at work or at school, or by institution, but it's something that I could take and put in my desktop, right? And so this changed the equation quite a bit, where now instead of having a lot of the work applications running on a remote server, and you have a rinky-dinky client asking the server to do the work, now the clients, right, were powerful enough that I didn't need the server, right? I could now install software right on my computer, right? And this is where the advent of floppy disks, right, and thumb drives, where folks were installing software on their desktops, right, and not relying as much on servers, right? But then in the 90s, we kind of reversed again, right, where now you have this huge infrastructure where everybody can access the World Wide Web. A lot of the applications are now being reconsidered that can run again on the server, right? Do a lot of the rendering on the server side, and browsers can ask for this content and be the user interface. And you see the first couple of actual applications, right? Of computational applications that used to be applications that you install on your software on your personal computer. Now you're moving back to the cloud, right? And you see now, there's a lot of software that at first, we used to, install on our computers that now are available as cloud applications, right? So, the Excels of the world, right? The uh, Word, right? PowerPoint. Now they have cloud versions of that, right? Google has cloud versions of all that software that used to be installed locally on your desktop are now applications that run entirely on the cloud, right? On their web applications. So what's next, right? Definitely, with the advent of phones and in the iPhone, right, and Android applications, right? Now everybody has a small little computer in their pocket, right? And so now web applications or applications in general, right, are reconsidering their sizes of the screen, and right, and since these are the most used of applications are in a small tiny screen, right? So all these applications need to reassess on how they are accessed, how they run, right, on a smaller screen, on at most a laptop, but perhaps an iPad, or even just a large phone, right? What's next in the 2020s? We're halfway through. With is the computer going to be embedded in our heads with the Neuralink, right? Connected to some satellite, right? That controls a remote robot, right? That's doing all the work for us. Who knows, right? And AI to rule it all, right? So who knows what's what's ahead. Yeah, so a little bit of the history on the server side, right? So a little progression on the server. So a lot of the work on the client server architecture, a lot of the focus at first was on the server, right? Since so these tended to be much more powerful machines, right? That most of the computation happened on the server, right? And then it provided some data back to the user interface for rendering, but most of the work happened on the server, right? And specifically in the early '90s, there was since the very first type of web pages, right, were static web pages. That's how Tim Berners-Lee came up with it, right, when he came up with HTML. And these were all static content, right? They were just static web pages that you could not interact with, right? So there was a lot of things that you could not do, right? So what about maybe weather applications that you needed to change over time depending on the current weather? You couldn't do that, right? How about being able to maintain a conversation where I have a shopping cart that I add content to an online? I couldn't do that, right? The server could not remember these things, right? So all changed in the early '90s, right, with the Common Gateway interface, where folks started to consider where a modifications or evolutions of the infrastructure on the server side, where not only could you ask for static content, just plain old HTML, CSS, and whatnot, but you could have URLs that invoked some function, right, on the server that would execute on the server. It would in some language, C++, Perl, whatnot, right, and then it would generate a response back that was compatible with the browsers, right? Browser are always expecting an HTML document, right? An HTML, something that's formatted as HTML. So the Common Gateway interface, right, introduced the idea that this HTML, instead of coming from a static HTML file, right, it could come from an executable. The executable could have a function that could calculate an HTML string that the browser would know how to render, right? And because it's executable, now you can have for loops, if statements, right? You can go out to the file, right? You can go out and do network connections. You can go out to the database, right? It just opens up an entire new family of things that you could build, right? And this idea just exploded. For us developers, was a gold mine, right, of what you can build, right? So there was a lot of efforts at evolving and building on this idea of running code on the server, right, initiated by a browser. The browser would ask for content, and that request would cause code to run on the server and would compute, right, the results, formatted in HTML, and send it back for rendering by the browser, right? And so this is the general architecture here, right, where Alice is asking at her browser for content that went out to the server, and the server, the server could run all sorts of languages. It could be implemented in Java and C Sharp, C++, PHP, Perl, Python, you name it, basic. And it would run some logic. It could be a huge program, right, that went out to the file system, databases, blah blah blah, out to the network, connect to the weather channel, gather all this information, and then send back an HTML content, right, that the browser could understand and then render it for the user, right? Now this idea evolved over time. The first breakthrough of this idea was in the 1990s, at the end of the 20th century, with that Sun Microsystems came out with the Java 2 Enterprise Edition, right, that introduced a nice infrastructure, right, of a set of libraries, right, that would allow you to build web applications on the server side, right? Then Microsoft responded with that with .NET, right? That opened up the number of languages that you could use to build these web applications, and this just iterated over and over, right? It became, then you have Ruby on Rails, Django, Flask, right? Using Python, and every single language now you could use for running on the server, and also JavaScript, right? In the early '90s, it was considered a language that would only run on browsers. But seeing all the great stuff was happening on the server, right? JavaScript, we created a Node.js infrastructure that allow you to run JavaScript also as to implement servers, right? So yeah, so a lot of great stuff happening on the server, implementing the fact that we're computing the user interface, right? What the user sees, we're computing it on the server, okay? So these server technologies generate the content that you see in the user interface. It's all rendered on the server, right? Now, also, meanwhile, right at the same time, in parallel, there were a lot of things happening on the client side as well, right? On the browser side. The first version of this was JavaScript. JavaScript is a language that usually associated with executing inside of a browser, right? Where the browser downloads a JavaScript file, executes it, right? And the JavaScript can control the browser, right? Telling it to render certain things, right? It can manipulate the data structures on the browser, right? And control it to tell it what to render. So it's used to implement user interfaces, right? Now, there was a lot of pushback at first, on this idea of downloading executable files from some server that it would run on my local machine. People balked at this and said, "No, I don't like that. I don't want that. What do you mean I'm going to download something that can execute on my machine on my local browser? That's kind of scary, right?" So there's some pushback on this. People would disable JavaScript, they would disable cookies, right? A little bit of paranoia. So there was kind of like a window there where Adobe provided the same kind of solution, but right sold it in saying that, well, this is not code that willy-nilly runs on your browser. Instead, install this plugin, the Flash plugin, right? And the source code compiled binary would be downloaded, and then it would run inside of this plugin in your browser. People were more open to that, right? Saying, "Oh, well, that sounds safer." No reason why it's any safer than JavaScript, but they were able to market it as something much more safer. Where it was um, a walled garden, right? That the application was not able to execute outside of that plugin, right? Certainly not access the file system and things like that. But JavaScript too. JavaScript was also evolving in such a way that addressed many of the initial risk concerns, right? Of privacy concerns and security concerns that the first versions of JavaScript and first versions of browsers were having, right? So again, they came up with assurances that JavaScript source code that was downloaded was not going to have access to the file system, was not going to be able to start perusing through your private emails, your private data in your file system. Very limited access to the network, right? That it could only connect to the server that it was downloaded from. So yeah, it addressed a lot of those security concerns, right? And so JavaScript evolved over time, right? And also at this time in the 2000s, you see a lot of the um, competition amongst the big players, right? Same thing, just like in the server, you see, Microsoft competing with Oracle, competing with some microsystems, right? Google, not yet. In a minute, in a bit. And so they were all coming with their own infrastructure on the server. Well, same thing on the client side. There was a lot of competition on which browser were people using, right? And there was a competition to see which browser, whether you were using Microsoft IE, God forbid, right, or Chrome or Mosaic, right, or Netscape, Firefox, right, Safari, and the idea was that whoever controlled the browser, right, controlled the world, right, because that was kind of like your window to the rest of the world, right? Everything was moving to the cloud. Everything was moving to the server, right? And the way to get there was through a browser, right? So there was a lot of competition amongst these folks. And what happened was that each one had its own version of JavaScript. Right? There was a standard, but because they were competing, they were trying to lure, right, the developers, right, to develop for them. Just like .NET was trying to lure developers to use the .NET infrastructure, as opposed to Oracle trying to lure folks to using the Java programming language, right? And so the same thing was happening in the browser. Same thing with iPhone and Android, right? Developers that focus on one or the other, right? And each one touts their better infrastructure. So same thing happened in JavaScript, right? In the browsers, you have different versions of the JavaScript language. So that made it a nightmare for developers, right? That they have to maintain multiple versions of their application so that it would run on Safari, it could run on Mosaic, it would run on Netscape, on Firefox, on IE, and so this this breakage in the infrastructure, right? This where you have multiple versions was very, very bad for developers. So jQuery came in, and what jQuery did was create kind of like a small, thin, virtual browser, right? Kind of like what Java tried to do. Java tried to create a virtual machine, right, where the same source code could then be compiled, right, to different CPUs, right, or different operating systems. So same thing, jQuery tried to do something similar, but for browsers, right, where you write your code in JavaScript, in terms of this jQuery library, right, so that then jQuery would then translate correctly, right, so that the same code would run fine on Mosaic, on Netscape, on Safari, on Chrome, or on IE. So it was the first introduction of the fact that you would have a thin layer of abstraction, on top of the browser, right? So you would not be talking directly to the browser; you would be talking through this library. So this idea, became very, very popular, and the very first breakthrough in this idea was by Google, Angular, in the 2010s, right? Where they having learned a lot from what happened on the server side, right? From all these infrastructures on the server side, they copied a lot of the best practices and the best ideas from the server, right? And they brought them over to the browser. Right, so it's okay. Well, we'll create a JavaScript infrastructure, right, that allows you to build very powerful user interfaces, right, using JavaScript on the browser, right. Now other libraries also came and went, so that kind of tried to copy this idea, but didn't have as much success, right. Not until in 2013, when Google came out with the second version of their Angular library, very, very successful Angular, right. But the second version was received with some skepticism, because yes, it was great. It was a huge improvement on the first version of Angular, but it was not backwards. Any code that you have written on the first version of Angular was not forward compatible, right, with the second version of Angular. So that meant that developers kind of had to like rewrite everything, right, with this new version of Angular. There was no there was no anything that you had invested already on the first version that you could bring over and port, right, into the second version of Angular. So a lot of developers and companies were left wondering whether perhaps if they're going to rewrite this from scratch, perhaps they should consider other infrastructures, right? And that's where React from Facebook was there, with open arms, right, awaiting all these folks, right, disgruntled developers, and say, "Hey, try us," and folks liked it. React.js had a very shallow learning curve; it's very, very easy, very straightforward. Whereas Angular, in general, is considered to have a very steep learning curve, right? It's a huge infrastructure, right? Whereas React, it's very simple. The only thing that React does is that it's a function that computes a user interface, right? It mixes and matches JavaScript and HTML syntax, right? It marries the two syntaxes, right? into a new sync that's called JSX, your JavaScript XML, right? So that you can run algorithms that can compute what the user interface is. So it's just a rendering engine. It renders stuff on the screen. That's all it does. Where Angular had tons and tons of other things that you also had to learn, right? It was way, way beyond just a rendering engine. So folks liked it, right? And they stuck with it. Certainly, there are many other new competing libraries like Vue.js, right? They're coming out that are following this same idea. But we're going to stick with React.js. It's still one of the more popular frameworks, right? And there's plenty of jobs out there that require using React.js. Now, in this new way of building applications, the user interface is not rendered on the server. So it's not using this implementation where the rendering happens on the server and then the HTML gets streamed back to the browser. Instead, right, what happens is that the browser goes out and asks for snippets of code, right, of HTML, CSS, JavaScript, downloads it to the browser executes, right, the JavaScript on the browser, and it computes what the user interface should look like. Now, it might be that this user interface needs some data, right? So it will have to go back to the server for the data. So now the server has a different role here, right? It used to be that the server computed the user interface, right? The HTML, no longer, right? It allows you to access the algorithms to compute the user interface in the browser. And it also provides the data, right? So if you need data from some database or from some JSON data file, right, you can go out to the server and the server will provide you with the data that can be used to render the user interface, right? So it's a completely different way of thinking, right? You render the user interface in the browser as opposed to the server.